This is the story of the physician, embarking on the quest to find solutions to unanswered eye problems, relying on his clinical research to guide him. But a desert lies between him and the fulfillment of his quest. Along the way, he discovers a friend in the basic researcher.
For a long time I've been trying to find the answer to posterior capsule opacification. And I know the missing link lies with you, in the tons of research work that you do in the laboratory.
It's quite simple. આમાં એવું છે કે જે LECs હોય એનું EMT થાય તો ડોલી કોલ ભેગું થઈ જાય.
I don't understand a word.
Determined to bridge the communication gap between them, they continue to walk towards the future.
Scalpel, sponge, magic wand. Begone, spawn of darkness. Do you not see? The only problem you are facing is that both of you are speaking different languages. Your quest will end in translation.
Found in translation. Basic research is performed without thought of practical ends. Often, scientists may be unaware or not highly motivated to pursue their research findings to bring out endpoint clinical applications. On the other hand, the function of applied or clinical research is to provide complete answers, like innovating a better drug, technique, or an instrument.
Sadly, scientists and clinicians often work in isolation, creating parallel tracks that never meet. It is translational research which provides effective translation of advances in laboratory research, ensuring that research knowledge and potential treatments actually reach the patients. Go ahead and explore the wonders you can create together.
With phacoemulsification being performed through smaller and smaller incisions, I have always wanted to know the integrity of these incisions.
Wait a minute, I have an idea. Can you perform coaxial phacoemulsification through 1.8 and 2.2 mm incisions in rabbit eyes? I will now use my tools of histomorphologic and immunofluorescence evaluation on the sectioned incision tissue. Notice that incisions exposed to 1.8 mm phacoemulsification have more stromal collagen shrinkage, keratocyte nuclear damage, ragged tunnel margins, and Descemet membrane loss. These changes are minimal in incisions exposed to 2.2 mm phacoemulsification. Immunofluorescence also shows a loss of parallel arrangement of type 1 collagen fibers in the 1.8 mm phaco incisions.
So does this mean that these incisions are more damaged, with compromised healing and sealing properties?
Precisely, my friend. Let's get further proof of concept.
Let me translate this into real surgery. I will instill trypan blue onto the ocular surface after stromal hydration of incisions. I will analyze aqueous samples using your tools of ultraviolet spectrophotometry for trypan blue concentration. Here too, the aqueous concentration of trypan blue was significantly higher in the 1.8 mm phacoemulsification group, confirming greater incision leak. Behold, we have been able to successfully marry our laboratory and clinical findings to bring out a recommendation for surgeons. Smaller is not always better. Beware of overlocking through tight incisions that leads to distortion and compromised incision integrity, in turn increasing chances of contamination into the anterior chamber. Additionally, an irregularly healed incision induces more astigmatism.
Therefore, smaller is better only
If combined with right instrumentation and IOL delivery system. Let's explore further avenues. Corticocleaving hydrodissection is known to reduce equatorial lens epithelial cell load and PCO. Nucleus rotation after hydrodissection frees the lens from the capsular bag, allowing stress-free maneuvering. But I strongly believe it also helps in better equatorial cell removal.
Come on, let's test your hypothesis. In one group, we will perform hydrodissection alone, and in the other, hydrodissection combined with nucleus rotation. Can you see that corticocleaving hydrodissection combined with rotation removed significantly greater quantities of lens epithelial cells compared to hydrodissection alone? Hydrodissection detaches the LECs and cortical fibers off the equatorial capsule. Subsequent rotation helps to sweep them off, akin to a broomstick. So I would recommend that all you surgeons can perform corticocleaving hydrodissection with nuclear rotation to reduce your PCO rates.
I see that you both have realized that basic and clinical research are not competitors. They are just different styles of approaching the same problem. But beware, becoming a physician scientist is not easy. The seeds of curiosity will have to be nurtured into the right research question. Then you will have to step out of your comfort zone and join hands with researchers in universities or laboratories. Devise the right research methodology, and hey presto, the sweet reward is personal and professional growth and the progress of science.
Developing the open-mindedness to see things in another light, to see things in a different way, can give us the ability to dramatically change the way we approach different situations. This is the essence of translational research.